Good morning. Apologies for the slight delay. The Macs are doing the usual Mac thing and giving us jip. Okay, for those who don't know me, my name is Daniel Hodder. I will be your Master of Ceremonies for this morning's Christmas Dev Guild event. As has become tradition, we did this last year, therefore it's now a tradition, the Christmas Dev Guild event is a little bit tongue-in-cheek. So this one is variations along the theme of mutants and testers must die. to that end, our first presentation by Jakub. I'm sorry, I'm going to butcher everybody's names because everybody here is from somewhere in the Baltic region, and I just don't have the right kind of tongue to say that. So, without further ado, on to Jakub, and our first presentation, Mutants Should Die.
Or statements were executed, branch coverage, which is about checking how many branches or paths of execution were executed during our test run, condition coverage, which talks about how many different conditions in our if statement, loops, and so on, how many of these different combinations of conditions were executed. Yeah, but code coverage gives us this confidence that we have good tests, but is it really so nice? Should it really give us so much confidence? So I would like to show you two examples of why it might be not so. So let's imagine that we have this multiply method. Simple method which takes two integers, produces an integer. And we get some implementation. Doesn't matter for this case what the implementation is. And we get a unit test, right? So we have unit test which executes which invokes this method, and then we check whether the actual result is the same as the expected result. Pretty simple. And in this case, we have test passing, and the coverage is 100%, right? So it should be all good, all good. OK, and everything is perfect if we have this situation, this implementation. So we say, yeah, life is beautiful. We can sleep well. But let's say that we got a bug in our code, right? So someone had just didn't implement it the way it should be implemented, introduce a bug by regression or introducing this method, and just nobody noticed that. So what happens now? We still have test passing, and we still have 100% coverage. So what? We have a bug, but tests are passing and 100% coverage. This isn't right, right? So we get this false impression that our tests are good, that our tests are covering all the cases because we have 100% coverage. So we should be really happy while we have a bug in our code. Another situation is like this. So we have our implementation with bug, and we have this test. So as you can see, somebody just forgot to introduce an assert there, right? So still, we execute our code, but we don't check anything. So again, we have test passing, and we have 100% coverage, right? All is good. Life is beautiful again. But our test is really crap. So how do we really measure unit test quality? Is there any other way that we could use? Are there any other tools for unit tests? Maybe you should create unit tests for unit tests for unit tests, right? All right, fortunately not. There is another method to choose. And the method is called mutation testing. So this is where we will create our mutants and where we will try to kill them. All right. So let's have a look at the simple example. So, oops, almost is. Cool. Yeah. So what happens with mutants is that we have our implementation here, our production content, our test here. And with mutants, we mutate our code by introducing these mutants. So we change our production code. We don't change our tests. We just change the production code. So let's say that we, oh, sorry, I went too far. Yep. Yeah, so let's say that we change our code. So we change the operation here. So in your opinion, what should be the result? Should the test be passing still, or should it start failing? Failing, right? Because we change our code, so our test should be able to detect that. So in this case, almost good. Almost what I wanted. So now imagine that we change this to plus, OK? Just imagine that. That was my fault. Sorry. So if we mutate our code, the test should stop passing. But in this case, even if we exchange the asterisk to plus, the test would still pass, and we would still get 100% coverage. But so it means that the mutant would not be killed. We wouldn't detect the change in our code, right? If we change the asterisk to plus, the operation. So yeah, what we want to do, we want to be able to detect these changes. OK, so what mutation testing is? This is about changing our source code by introducing small changes like this one, like changing algebraic operation. Then we run our tests against the mutated code. So we have our code changed, and you run our tests against this mutated code. And then basically, as a result, our tests should fail because they should be able to detect this change. So let's have a look at another example, which should be good, I hope. So let's say that we have this square root method, which takes integer and produces another integer. And we get a test which passes. So again, we invoke our method, and we compare the results. Test passes, all is good. But then we introduce a mutant. So we change this to, let's say this, right, again. So in this case, our test fails. And we can say that the mutant was killed. So we can be kind of glad that we had this test. So this test was kind of good enough to be able to detect this mutation, right? While the other test with the multiply method wasn't good enough to detect our mutation. This test was good enough. So we can have different kind of mutations. So one of them is map mutator. This was the mutator we could see already. So we have some operation, and we mathematical operation, and we just change it to something else. This is one way of introducing mutants. So introducing different algebraic operations. Then we can have different kind of mutants, which is about changing the conditions in our code. So let's say we have this if statement, and this can be changed to something like this, or to something like this, right? Again, our test should be able to detect this change. We can have something different. We can have this mutation, where we have, when we invoke some method, and with our mutation, we just remove this call, right? So again, our tests, our unit test should be able to detect that we change this, right? If we stop converting, if we like this, stop converting our number, our unit test should be able to say, okay, you just did something different in your code. Okay, now you might be wondering, so do we have to do it manually? Do we have to introduce these changes manually? Fortunately not. So we have some tools which can help us with that. And there's a number of them. So for example, there's Jumble, which is a mutation testing framework from New Zealand. But it's not maintained anymore, really, so I won't talk about that. There's Jester, which was first open source framework for mutation testing. And it's kind of also not maintained anymore. There is Mutest, which is a tool integrated to EvoSuite, but I don't know what EvoSuite is. So I will talk about PyTest, which is an Eclipse plugin. This is also a command line tool, so you can just run it from command line. But you also can install the plugin for Eclipse, and you can just run it against your code. And as a result, you're going to see this kind of a view with a report of running all your tests against the mutated code. So what does PyTest do is that it first it runs your test without any mutations introduced, and it checks how long each test took. How long each test took, so that it has some baseline, some benchmark to compare the mutated code later on too. Then it introduces one mutation, runs the test. Second mutation, runs the test, and so on and so on. So it's not that it introduces all the mutations at once. It just is one by one introducing mutations, running all the tests every time. That's why it takes a bit of time to run all of these things, all of these mutations. It's not as quick as just running unit tests. Okay, and as a result, we have this report, and we can have different categories. So our mutants can go into different categories. So first, we have killed mutants. So these are the mutants which we really like. Our tests were able to detect the change, and were able to kill these mutants. So our tests were kind of in a good shape. But we can also have the survived mutants, so the mutants which weren't killed. So we introduced some change to our code, and we weren't able to detect that with our unit tests. So this may be an indication that maybe we should go and have a look at the unit tests, at the code maybe. Maybe there's something wrong that we might need to improve. Maybe we need to add some more cases to our unit tests. Maybe we should introduce some parameterized tests like Jakub will be talking about. So maybe there are some more stuff to do in our tests, or maybe in our code. So this is the things that we want to have a look. No coverage category is similar to survive category, and we should have a look at these cases. And basically, these are the mutants which were introduced, but they weren't really invoked in our unit test. So this is kind of the same as code coverage. Then we can have non-viable mutants. And this is because PyTest introduces the changes on a bytecode level. So sometimes it can introduce the change on the bytecode level, and the bytecode might not be able, and the JVM might not be able to load the bytecode after the mutation. There might be some cases. That's why these are these kind of mutations. So we shouldn't really worry much about that. Then we can have also timeout mutations, which means, or you can imagine basically you have a while loop with some condition, and then you change the body of your loop so that it starts to run endlessly, right? Because you mutated your code, so it's going to just run endlessly. That's why PyTest first runs your tests without mutations. It checks how long the method should normally run. Then it runs the mutated code. And if the mutated code runs just too long, it knows that it is probably the mutation introduced endless loop, and it's going to kill that test, and it's going to put that mutant into the timeout category. So we also really shouldn't worry much about that. And there's memory error, which is similar to timeout mutants, because because of the mutants we introduce, we might run into a situation when we just create too many objects, right, in a loop or in some other way, and we just get it out of memory. All right, so how do we really measure our unit test quality? So we have code coverage, which is good. I'm not saying it is bad, because it can give us very quickly some understanding of our code quality, unit test quality. But we also should consider, or try consider mutation score. So we can run it, I know, at the end of the sprint, I know, at the end of release, whatever, because it takes time. And it takes also, we need to investigate some time to have a look at all the cases that, all the mutants that survived. But I think that we should start looking at that in order to be able to really see how much our unit test sucks or how much they rock, really, right? All right. Any questions? I think maybe one question. Yep.
Just before you do, reminder, we are streaming live to the world, so no internal stuff, please. So no running to internal anything that's around it.
Right, okay. Can you give us some kind of idea of how long these tests take to run? I mean, it's one thing with a simple calculator package, but where we've got unit tests that might take a minute to run some suite of unit tests, are we talking a few minutes or a few hours or what?
So all the other frameworks, they used to be kind of naive, and they didn't optimize it well, but PyTest is pretty good with that. So it knows, for example, which tests to run against which mutated code, so it doesn't always run all the tests. It knows which test executed this line of code. So it's kind of optimized in a good way. But it takes, I know, at least, basically depends. It's much, I would say it's 10 times longer than just running normal tests. I would say that. It depends on many factors, but yeah. It is longer, but not huge longer. Cool. Okay. Now it's Jarek's time.
Thank you.